Okay, so these videos we are going to focus in hyperbolas, okay? So the equation of the hyperbolas, we are going to have two equations, depends if there is vertical or horizontal, okay? So if we have the horizontal axis like this one, that the axis of symmetry is right here in the middle. For this equation centered in the origin, we have the next equation that is x squared over a squared minus y squared over b squared equals to 1. Okay, never forget the 1 because if you forget the 1, Alex will take you the answers back. So for this equation, we are going to have the vertex in plus or minus a comma 0. Okay, and the foci is going to be in plus or minus c comma 0. Okay, so for the one with the vertical axis, we are going to have the equation. We are going to start with y squared over a squared minus x squared over b squared equals to 1. Note here that here we have a similar equation like the helix, but this equation have a negative symbol. And when we have the positive symbol with x, this is going to be a squared. And when we have the positive symbol with y, this is going to be a squared. Okay, so for this one, the vertices are going to be 0, plus or minus a, centered in the origin. And the foci is going to be 0, plus or minus c. Okay. Now we are going to know what is c. Okay. So c in the hyperbola, we are going to have c squared is equal to a squared plus b squared. With the difference of the helix, remember that we have the helixes, and we have that is c squared equal to a squared minus b squared. And there always a was bigger than b. But in the case of the hyperbola, this is not going to be true, okay? So this was for ellipses, and now we have this for the hyperbolas. So let me write here this one so that you will not be confused, okay? So this one, forget about the equation for ellipse, so no problem. Okay, so now we have that c squared is equal to a squared plus b squared. This is going to be for hyperbolas. And now we have the equation for the asymptotes, okay? The asymptotes. The equation for the asymptotes are going to be when it's horizontal, it's going to be y equal to plus or minus b over a times x. And for the vertical one, it's going to be y equal to plus or minus a divided by b times b. This is going to be the slope. Okay, this is going to be in, this is going to be in. And this is always when the hyperbole is centered in the origin. I'm going to talk about when it's out of the origin, but in the video later, okay, later. So let's start with one problem. Okay, let's start with one problem. Let me move to here. Okay, we have x squared over 4 plus y squared. No, sorry, minus. Here is minus because minus y squared over a over 9 equals to 1. Okay, so here we need to identify a, b, and c. So to know where is a, we are going to have a always in the positive one. So here we have a positive, and this is going to be a, this 4. So a squared is going to be 4. So b squared is going to be 9. Okay, so a is going to be 2 and b is going to be 3. The square of this number, the square root of 9 is going to be 3. The square root of 4 is going to be 2. Okay, so now the center is going to be 0, 0 because this equation is centered in the origin. Okay, so now we need to identify the vertex. the vertex are going to be plus or minus a, comma 0, okay? And we have that the vertex is going to be plus or minus 2, comma 0, because a is going to be 2. Now, for the foci we have that is going to be plus or minus c, comma 0. So first we need to identify c. So we meet here c squares is going to be equal to a squared plus b squared. Okay. So c squares is going to be equals to 4 plus 9, and this is equals to 13. So c is going to be equal to the square root of 13. This doesn't have a perfect square root, have a perfect square. So it doesn't have a perfect square. We can let it like here, or we can say that is something like 3.6, 3.6 and more numbers. Okay, but we need to graph this. Okay, so to graph this equation, we are going to graph the equation. We are going to put the center first. So we have the center in 0, 0 here. And here we need to move 2 steps to right because this is going to be A and A is 2. So 1, 2 here. And we need to move 3 steps up because it's in the because B is down of Y. So the number 3 is going to be related with the Y axis. So it's going to be 1, 2, 3 here, right here. Okay, so let's put the let's put this. Okay, here we're going to move 3 steps to right and 3 steps to, no, sorry, we're going to move 2 steps to right and 2 steps to left. So here, also here, and 3 downs, 3 ups, we rise up and we go down also. 1, 2, 3. Okay, and here with this point that we have here, we're going to have 1 point here and another point right here, another point right here. With this, we are going to make a rectangle. Okay, we are going to create a rectangle. And this rectangle is going to help us to create the asymptotes. Okay. So with this rectangle, we have it here. This rectangle, we are going to write the asymptotes that are going to be the diagonals of this rectangle. Okay, we are going to create the diagonals. Diagonals are going to be these ones. Let's draw the diagonals. Going to be something like this. This is an asymptote. So this is an imaginary line, okay? This is going to be an imaginary line. Okay, so now we have the center that is right here, and we can find the vertex. The vertex, as we say, is in 2, 0. Okay, so it's going to be right here, the vertex. Okay, this one that I'm drawing is going to be the vertex. Here, let it put it with the purple one. Okay, here. And also in -2, 0, we have the other vertex. So we have this one and this one. So now to try to draw the hyperbolas, we need to draw this even touching the asymptotes, but not touching them, okay? So we are going to draw something like this. kind of difficult. Okay, so now we have the asymptotes. Okay, so now we need the font size. The font size is going to be plus or minus c comma 0. So we say that this square root of 13. So we have the font size is going to be plus or minus square root of 13 comma 0. So square root of 13 is 3.6. So it's 1, 2, 3, 4. So it's going to be something like here. Approximately here is going to be the foci. This is the foci. Also here we have the foci. Okay, so this example, we are going to know that here we have the foci. Okay, and let's go back. Let's go back with the examples. Here in this example, we have that the difference between the center and the vertex is going to be called A, okay? And C is going to be the distance between the center and the foci. So this is going to be called C. We have that the distance between the two centers is going to be 2A, because here we have 1A, so this space is the same measure, so we have 2A. And the distance between the foci and the center, the two foci and the centers is going to be called 2C. Okay, so questions until here? Any question? ¿Están poniendo atención? Solamente está poniendo atención. Okay, so now we need to have the equation for this asymptote. So it's going to be y equal to plus or minus b over a. This is going to be right over wrong. Okay, right. As b is going to be in right, we have b over. We're wrong in b, and we're right on b, and we're wrong on a. Okay, so it's going to be b over 8 times x. That is going to be y equals to plus or minus. We have that b is going to be 3, and a is going to be 2 times x. And this makes sense because, as you can see, we are going to have two lines, one that goes to right, that is going to have a positive slope, that is going to be y equals to 3 over 2 times x, and we are going to have x equals to equals to 3 over 2 times x, but this slope is negative because, as we can see here, one goes to left and the other one goes to right. Okay, so this is going to be the slope of this equation. So now let's go back to the explanation. You can pause the video and go back if you want. A ver.